All right, everyone. So next presenter is Izu-san. Izu-san is the founder of eLab, which is my main support.
Okay. Let me introduce about eLab, what we are doing. So skip some slide. So we are making a couple of different vehicles, not only UAV but also the UGV. So I will show you those vehicles and the other technologies like AI. I will use video. So at first, basically the eLab is very focused on the solutions, how to use those vehicles or how to use those technologies to apply to the social. That is the main purpose. So this, basically we are making the unique items. Just take picture, you can buy the DJI, but we are focusing on the solutions. So this case is designed for fire department. So which means carry the special chemical on fire and drop into the fire. Such kind of application. So fly on like this, and even the expose but still fly. I expect new Reuters.
You've just got to get some help tuning it, I think.
So anyway, later the Randy will explain what happened in the fire. Okay. So, but and also the UGV getting popular. So we are making this kind of vehicle. So the vehicle is safer than UAV, so getting popular. And also the boat and the submarine like RAV. Same time we are analyzing the what kind of behavior by this kind of simulation. And also we are making small electronic hardware, like the transmitter or telemetry system. And especially I like this one, which is Jetson, come from the NVIDIA, which is a very, very clever company computer. We are using this on the vehicle as a AI, the brain. So RTK, you already know. And how to use AI is one is avoid from the object. For example, in this case, also Randy mentioned before. And another case is recognize the area. For example, this case is a castle is the area. Other than castle is a forest. So if the drone, something happened, so if pilot there, the pilot think about where I have to go down. Same things, the AI can recognize which is much safer. So that go to forest or go to river, the point falling down. And the other application is the search and rescue. Try to find out people or the items. So from drone, try to find out where is rescue people, where is injured people, those things we could find out. Use deep learning technology. That's correct. And this will be explained later by Randy. Okay, so another amazing thing is this case. This is a picture, and this is the same place and the use depth map. The dark black is far away. The white space is closer. So the learning those pictures, then the deep learning could understand. For example, this is inside, but based on this running data, you can see the very hard to see, but the AI could understand which item is far away or closer. It looks like if you watch something by single eye, you can decide which is far away. So same things the deep learning can do. It's amazing. I don't know why, but it's possible. This is good for the vehicle, I think. And next is SFM. So recently the use drone for inspection, that's demand getting popular. So we need the 3D mission plan, like the 3D mission plan. So which means, for example, this is our building. So the customer wants to fly, keep 1 meter distance from wall, and autonomously fly around the building. Then we need to find out, we need a 3D model. So this case is take video from around the building and make up this kind of 3D model. Even the power line, it's very hard to see, but it's possible to find out power line. So power line is very dangerous for drones. So also that it's possible to make up the 3D map. And okay, so how to make this SFM is use this kind of drone. This drone has a 3 camera in here, and at the same time take picture. Of course, the 1 camera also okay, but if the power line moving by window, then very hard to find out. So the idea is use 3 camera in drone and build up this kind of 3D map. And when you use deep learning, make learning data is very important. So we are making the lab agent, which is a cloud system. So you can access to this server. Then you can browse some kind of things. For example, this case is a tomato picture. So just choose tomato by mouse. Then it's easy to run, annotate the data. This kind of interface also we are making. Also, we are thinking about cloud system with 3D mission plan, something like this. So we apply to our technology to many customers. For example, this case is deliver the medicine to a small island. So there is a box, a couple piece of box, and delivered by tether. And when the box touch down in the ground, the payload getting lighter. So autonomously unload the box. That's kind of idea. So this application also prepared by Lambda. Anyway, your technology is very useful for social. So I want to keep good relationship with you guys. And also, we are making a couple special vehicles. So I can donate this team any vehicles if you want. So please ask me if you need those vehicles. Okay, thank you.
I have a quick question about that. Okay. For your vision things with the NVIDIA TX systems,
Is that part of the AP Sync or anything, or is that open source at all?
Yes, almost. Many great things about eLab, but one of the great things is almost everything they do is open source. So OpenKite is included in AP Sync, and let me just grab the roller. So this is one of the rovers, and it's got this is the indoor rover, and it's got a TX1 in here, or a TX2, and that is running OpenKite, and it's got a 3D Z camera on the front. And so OpenKite is responsible for getting the depth data and also the visual odometry data from the Z camera, and we pass that in through MapLink, and then Paul has enhanced the EKF so that we can absorb that, and so that's how we can do indoor navigation at the moment using visual odometry, and also can do object avoidance as well using the depth. So,
I was specifically asking about the keeping their distance from the wall. They did an example of doing that from helicopters. That's available as well?
Not yet.
yes.
Eventually, can the plan just be that, or?
Yeah, hopefully.
Nice.
All right. So next thing is just the playing fire video. So the full. It's quite a difficult environment, as you might imagine, and I'll show a couple of graphs later of some of the sensor data that we're getting out of the Pixoc 2 that's on this vehicle, but also. And I'll also show some pictures, some close-up pictures of the vehicle later. But you can imagine it's not just a normal carbon fiber frame because the temperature on the external part of the vehicle is about 100 degrees Celsius. So you'll see some pictures, but it's got aluminum plates on the wall around it, and also eLab is working on some special propellers as well. To be able to see.
So Randy,
yeah.
what temperature you got a heater on the inside of the Pixel 2 sensor then?
It's actually almost. Actually, this vehicle is pretty much default Ardu opera.
Yeah.
There's very few setting changes actually. So you can see it loses attitude control.
That's that one you showed me with it.
Yes.
It's not even tuned, is it?
That's right. Yeah.
That's default.
So I also want to ask. What other jobs can you do where you get to do this kind of fun stuff?
Fantastic. Yeah, honestly, that actually should that.
Okay, so
going like crazy.
next I'll just show you some of the. It's actually not quite as extreme as you might imagine. This is from, first of all, is the temperature. So the outside of the vehicle, we've measured it externally at 100 degrees Celsius, but inside, you can see the graphs, hopefully. This is only 30 degrees, 35, 40, 45. So we're under, the IMU at least is reporting under 50 degrees inside the case. I suspect that there's some filtering going on though, so maybe that's not the instantaneous temperature. It's not terribly extreme. Here's the altitude. So the green line is the barometer. The GPS is in blue, so that's probably more accurate. And then what the EKF's altitude is reporting as. So the EKF seems to be doing quite a good job. Actually, for this test, we turned off the barometer, so we changed the EKF out source to be the GPS. So EKF did pretty well. The barometer is seeing disturbances of 5 meters or so, which is not a lot worse than we see during landing in some vehicles.
So RTK GPS would be a good alternative for you, right?
Yeah.
You don't.
Doesn't like that.
And this is the attitude. So not such a pretty picture here. This is just the roll desired in red. Just so you can see it's quite close to 0 most of the time. But then the roll actual is in green, and this is 50 degrees here. So you can see in some cases it's going well beyond. Yeah, I think the maximum error is off 102 degrees. but this vehicle needs to be tuned. So some of those things came up in Leonard's talk, including setting the maximum acceleration much lower. Will stop it from, should improve.
Those are stopping, completely stopped pizza,
Completely stop.
which is not.
And the vehicle is larger than, say for example, an Iris. It's about this big. Yes, here's some pictures. This is the outside of the vehicle. It's a quadcopter. 18-inch.
8-inch and the zirconia paint.
And here's the aluminum.
What were the propellers made out of? Are they
The inside is carbon, but
Right.
the outside is
aluminum
zirconia.
zirconium?
Zirconia, that which is a kind of diamond.
Oh, cool.
It's
Zirconia.
expensive.
So no issues with the resin softening and the composites?
Sorry. Sorry. Want to repeat the question?
The resin, right, that would hold the carbon fiber props together or the booms, no issues with that softening?
I think the propellers were damaged, right, in the fire test.
Yeah.
Didn't
Yeah.
find that they slightly
The band and the band. But don't clarify the power, so it's possible to use that.
I think there's also some talk of maybe making metal propellers.
But anyway, I surprised the fresh air always come in, so not getting high temperature. The fire itself is at 800 degrees.
All right. Here's a picture of the side of the propellers, and also there's a little guard around the motor to try and protect it. And that's it. So, part of this presentation was just to gather up some ideas. So, obviously, we can tune the vehicle more to improve its attitude control in the extreme conditions. But, Paul and everybody else has some suggestions about further improvements we can make to improve control. Good. There's also some talk of wanting to be able to fly indoors as well. So then the GPS all of a sudden is not an option anymore for the altitude control. The LiDAR probably also won't work because it'll be disrupted by the smoke coming up. Some of the other solutions that we already have, like the visual odometry, using the 3D camera, probably also won't work with all of the smoke. So
UWB.
right, okay, yep, UWB, ultra wideband. You have those little pods that you can deploy and
Or straight up radar.
Is there a radar tender that we support?
right, radar could go through the smoke. Yeah. Okay, so that's it, I think. Right, thank you very much.